Welcome to the video where we share some of the science and engineering behind fidget spinners and hopefully help explain just how they work the way that they do. And the first topic that we want to address is something that we mentioned in the last video, and that's a bearing. Here's a quick picture of a bearing, and before we share too much about them, can you quickly pause this video and brainstorm or ask yourself, what are bearings, or how do they work, or why do engineers design them in their machines? You got it. And just to add to that, ball bearings reduce friction and allow things to move smoothly by using these small metal balls that roll between two surfaces. Think of it like putting a bunch of marbles in between your two hands to allow them to move smoother and faster. And think about it, when engineers design them in their machines and systems, it allows two parts to move around each other and spin around each other really efficiently. And I know we mentioned a few applications of bearings earlier, but now, check them out in action. And there's just one more topic that we wanted to share with you real quick. When something is spinning around an axis, it has what's called angular momentum. On top of fidget spinners, some more examples where angular momentum is present are a spinning top, a carousel, or even, if you think about it, planet. And this may or may not make sense quite yet, but the faster something is spinning and the heavier it is, the more angular momentum it actually has. Another way to think about what I just said is that the harder something would be to get to stop moving, that means the more angular momentum it has. Check out this versus this. Which one do you think has more angular momentum? But anyways, since objects want to keep spinning and keep spinning in the same direction that they have been, that's why you feel that weird sensation when a fidget spinner is moving and you try to change its axis of rotation. It pushes back on you. Let's think about that a little bit further. If a fidget spinner is upright, it's spinning along a vertical axis, and because of angular momentum, it wants to stay there. But when you change it, say 45 degrees, you're trying to change its axis. And you can feel the physics of the axis changing and the object pushing back on you because of Newton's laws. And to wrap this topic up, angular momentum relies on an object's mass, shape, and speed of rotation. So those are all things that we can keep in mind during the next video that we can change and tweak to make your fidget spinner unique. And it's even a conserved quantity, which means it's not going to go anywhere unless it's acted on by an external force. But that's a good segue into our next topic, because speaking of external forces, we have to deal with friction. See, in a perfect world, these fidget spinners would keep spinning forever because the only force acting on them is gravity. But we do have to deal with friction, like we said, and friction occurs when two objects rub against each other, and it's not exactly good in this case. And that's because the bearings that these fidget spinners are built around do create a little bit of friction. All the moving parts inside them, even if it's just a little bit, do rub against each other, and that's what makes the fidget spinner want to slow down. And it's a slippery slope from there, friends. As the bearing does slow down, it loses a little bit of angular momentum and eventually comes to a stop. That's why we put things in cars like oil, which keeps the bearings and other moving parts well equipped and maintained to keep rubbing against each other in a healthy way. So let's tune into the next video where we're going to share with you just how to build your own fidget spinner, customize it, and have a lot of fun with it along the way.